In previous video we have learned about the reduced row echelon form and how a solution can be performed for a system of linear equations. So in previous video we have considered the case where Ax is equal to 0, and also we have seen this example also. Second example we have seen this example in which we are having a right hand side, that is a b value 42.8. In such cases, how the solution to the system of linear equations can be formed, that we are going to see. So we can take a b that is 42.8, and the pivot columns also we can consider, that is 1 0 and 0 1. So the equation formed will be like 42 C1 plus 8 C2 will be equal to the b value, that is b. Okay, 42C1 plus 8C2 is equal to b. So the solution that can be formed from this is C1, we will be taking the indices of the C1 and C2. So C1 column, it represents what? It will be representing the x1 variable, and C2 column will be representing the x2 variable. So for x1 we can take the value as 42, that is the index of C1, and for x2 we can take the value of C2, that is the index value of C2, that is 8. And C3, C4, it is not there in the formed equation, so it can be taken as 0 0. Okay, so it will be a vector of the form 42800. Since it is represented like this, it is taken, that is a transpose will be the correct, that is a column vector it will be. Now it is shown in the form of row, isn't it? So in order to take it as a column, we will be representing it as transpose. Then to compute all the other solutions, so this is just a particular solution that is being computed. To compute all the other solution, we need to express the non-pivot columns. As said in the previous video, we need to represent the non-pivot columns with as pivot columns. Using the pivot columns, you need to represent the non-pivot columns. So how we can represent? Consider the column 3. Column 3 we can check. So column 3 will be equal to, how you will be able to write 8 C1 plus 2 C2. Okay, column 3 can be represented using the non-pivot columns that is coming to the left hand side of column 3, that is C1 and C2. We can write like this. So from this you will be able to formulate like which implies 8 C1 8 C1 plus 2 C2 minus C3 will be equal to 0, as it is representing the equation of the form Ax is equal to 0. Okay, so same thing it is written over here also, that is instead of here derived equation there is no C4, so here it is taken as 0 C4, and from this you will be able to derive the solution for the tuples x1, x2, x3, x4. How? Taking the index values of C1, C2, C3 and C4. So the index value of C1 is 8, so here 8, x1 value will be x2 is 2, index value of C2 is 2, C3 index value is -1, and C4 is 0. Hence you will be getting the values of x1, x2, x3 and x4. So this is the tuple that will be formed, or vector that will be formed, and scaling of this vector, it will be producing another solution for the linear equation Ax is equal to 0. How it is producing? Lambda 1 8 C1, C1 indicates the column vector, and plus 2 C2 minus C3 is equal to 0. This is the way in which scaling of the particular solution obtained will be producing the 0 vector. Similarly, we can find the solution for the fourth column also. Now we have considered the third column, that is a non-pivot column, and fourth column also similarly you will be able to apply the solutions or apply the concepts and get the solutions. So you will be getting the solution like this, that is -4, 12, 0 and -1. And so two solutions you will be getting. Combining those two solutions with the particular solution that is generated over here, you will be getting the final general solution. Okay. The next is like a -1 trick example. So the previous one is reduced row echelon form. Using the reduced row echelon form, how we solve the linear equations. And next is like -1 trick. Using -1 trick, how we are going to solve the linear equation. So here also we are considering one matrix A, the same matrix that we have discussed in the previous example. And what you have to do is, first you need to augment the given matrix into a 5 by 5 matrix. So here how many variables are there? 5 variables and 3 equations. From the matrix itself you will be able to understand there is 5 variables and 3 equations. So you need to augment this matrix into 5 by 5 such that all diagonals will be having the element. Okay, so here's pivots are placed like this, and pivots are placed in these columns. So there are some missing rows which can have the diagonal value as a pivot. Okay, so you need to insert those rows. So while inserting those rows, you need to insert in such a way that the diagonal will be taking the -1 value, and rest of the elements inside that row will be 0. Okay, so you need to augment the matrix into 5 by 5 matrix, inserting -1 on the diagonal part where the pivots are missing. So in this case, the actual rows given in the question were these 3 rows. So 2 rows we are inserting with -1 in their diagonal position. So these 2 rows were missing that diagonal, missing that value in the diagonal. So inserting those 2 values, we can see a diagonal with all the elements as 1 or -1. So new rows when you insert, and when you insert some value to the diagonal elements, the value should be -1. That we need to remember. And then we can find the solution directly from this matrix, considering only the columns that is having -1 in the diagonal field. -1 in the diagonal part, which all columns is having -1 in the diagonal part, that column you need to consider, and that will be forming the solution. So here the diagonals -1 is coming under this C2 and C5. So the solution will be written like lambda 1 C2 column you will be taking 3 minus 1 0 0 0 and lambda 2 C5 column. Okay, so this is the same solution you will be getting in the previous example also that we have discussed earlier. You can just check it with the previous example. And one more example we have discussed in reduced echelon form. In that case also you can apply this -1 trick. So what here, how many rows? 2 rows and 4 columns are there. So you need to transform the augment the matrix into 4 by 4 matrix such that the diagonals will be filled with -1. Okay, so 2 rows are inserted in addition, in inserting -1 in the diagonal field. Then you need to consider the diagonal -1 that is coming, a column that is having -1 in the diagonal field. 2 columns are there. So those columns will be giving the solution. That is the solution for the equation Ax is equal to 0. All solutions to Ax is equal to. We are considering only that matrix. So we can see that the same C3 column forms the one solution, and C4 forms the next solution. This is the same solution you will be getting in while reducing it in the reduced row echelon form. And this one is the particular solution for Ax is equal to B. Okay. Next is like we can apply Gaussian elimination in order to calculate the inverse matrix. In order to calculate the inverse matrix. So given one matrix, how a matrix is given like this. So you need to calculate the inverse of this matrix, that is A inverse. So how? By applying the Gaussian elimination method you will be able to compute. For that, first you need to augment the matrix like this. That is, this is a given matrix. Insert the identity matrix together with that matrix. Okay, augment the matrix with the identity matrix. The size of the matrix will be same as that of the matrix given in the question. And then you need to perform the Gaussian elimination in order to convert this matrix, the whole matrix, into a reduced form. So this is the result obtained after reduction. So for that, some sequence of steps will be performed, like R2, that is, you need to transform the lower diagonal elements to 0, isn't it? You need to transform the lower diagonals to 0. Also here you need to change this matrix to a reduced row echelon form. Okay, you need to change the matrix to a reduced row echelon form. So what is the meaning of reduced row echelon form? In that case, if any pivot element is there in the diagonal part, then that column will be having only one non-zero value. The rest of the values will be equal to 0, and that non-zero value will be equal to 1. Okay, so keeping all this in mind, we will be converting the given matrix and you will be getting the result like this. You can try this example and see whether you are getting this result. These were the different operations performed on the matrix to get this result. And once we get this result in the reduced form, we can see that the second part, this will be the A inverse of the given matrix. And in order to check, just compute A inverse, multiply A matrix with A inverse, and if you get the identity matrix as a result, then we can say that the answer what you got is correct. Next and final thing is the algorithms for solving a system of linear equation. So if there exists a solution, means making use of the different concepts, you have generated the solution for the equation. If there is no solution, then an approximate solution can be formed using linear regression method, or else there can be some other representation like this.